The formula for potential difference. This is energy dissipated over charge. You can also call this is work over charge. The same thing is you can write. So V is equal to W upon Q, or V is equal to E divided by Q. Work or energy, any one word we can write. And if you cross multiply charge on other side, then you can write energy is equal to charge into voltage. V is the potential difference or voltage multiplied by charge. That becomes energy or work. And also we know that this charge, this is equal to current into time. So you get current multiplied by voltage multiplied by time. This is the electrical energy. There is a small example to understand this basic concept. The energy dissipated in a bulb is 30 joule when a charge of 6 coulomb flows through the bulb. What is the potential difference across the bulb? So simple is that formula is energy over time, energy upon charge. Energy is given 30 joule and charge is 6 coulomb. So you will get 5 volt. Achha, this answer you can write 5 volt or you can write 5 joule per coulomb. Keep it in your mind, volt or joule per coulomb. Any one unit you can write. Now there is another example. Just see this example. Solve this example quickly. This one. Time is given in minutes. Remember, you have to change time into seconds. Time should be in second. In the first part, you have to find out the charge. This is a product of current and time. Current is 2.5, time is 10 minutes. Multiply by 60, you will get 600. So charge, you will get 1500 coulomb. And then you have to find energy, which is charge into voltage. So these are basically small numericals. Keep it in your mind. This type of the small calculations you can have in multiple choice questions as well. The next concept is the resistance. Resistance, its actual definition is it is a ratio of voltage to the current. This is a ratio of voltage to the current, voltage or potential difference to the current. R is equal to V upon I. It is measured in ohm. And remember, 1 ohm, this is a sign of ohm. This one is a sign of ohm. And 1 ohm, that is equal to 1 volt per ampere. When you will write some numerical, then along with the answer of resistance, you can write unit ohm or you can write V upon A, volt over ampere. Actually, resistance definition is it is a ratio of voltage to the current. But what is the purpose of this resistance? What actually it does? Resistance is opposition in the flow of charges. Whenever in some circuit resistance increases, remember current will decrease. Whenever resistance in any circuit will increase, the current will decrease. Actually, resistance is opposition in the flow of charges. And remember, resistance of any conductor that is directly proportional to its temperature. If temperature of the conductor will increase, conductor, what is conductor? Metal, copper, aluminum, silver, gold, all these are conductors. Usually we utilize copper and aluminum, which are good conductor for electricity. If you are using copper wires or aluminum wires, if their temperature will increase, they will become hot, then their resistance will increase. And ultimately, remember, whenever resistance will become high, the current will decrease because energy of the charges, it will waste in the form of heat. Whenever resistance and temperature increases, then energy supplied by the battery will convert into heat. So ultimately, due to increase of resistance, current will decrease. So resistance is opposition in the flow of current. There is a small calculation for the understanding of the formula. Current in the ammeter is 0.5 ampere and potential difference is 6 volt. So what is the resistance of the lamp? R is equal to V upon I. You will get 12 ohm. This is the sign of ohm. You can also write 12 volt per ampere, V upon A. You will get the same thing. Now, there is another very important concept. Resistivity. Resistance of any wire. You know that the resistance of any wire, it is directly proportional to its length. If suppose there is one small length wire and there is one long length wire, Longer wire, always it has high resistance. So resistance is directly proportional to length. And resistance, it is inversely proportional to cross-sectional area. Cross-sectional area, what is it? I tell you. This formula, I have to introduce one constant over here. I write it. Remember, resistance, number one, resistance is directly proportional to the length of the wire. Secondly, resistance is inversely proportional to cross-sectional area. What do you mean by cross-sectional area? Like suppose that if there is some wire, this circular area of the wire, this is called area of cross section. Area of cross section. Its formula is pi r square, where r is the radius of the wire. This radius also you can write in terms of diameter. If diameter is given, then you know that the diameter, if you will make it half, that becomes radius. This formula I can also write in this way, pi d square upon 4. Area of cross section you can calculate in terms of radius, which is pi r square, or you can calculate in terms of diameter. This becomes pi d square upon 4. And if this area of cross section, if it is smaller, then resistance will be larger. It means that if there is a thin wire has small cross section area, so its resistance will be larger. And on the other hand, if cross sectional area of the wire is larger, it is a thicker wire, then in case of thicker wire, area of cross section is larger, so resistance will be lower. So resistance is inversely proportional to area. If we combine these two relations, we can write L upon A. Instead of this proportionality sign, we write equal and we write a constant rho. This is a rho, symbol of density. This is a symbol of density, but in this case, this is not representing density. Rho, R-O-W, rho, Greek notation, which is used for the density. But in electricity, this symbol is used for the resistivity. This is called resistivity. You should know resistivity. And remember, its unit is ohm meter. Resistivity, it is measured in ohm meter. This is a sign of ohm into meter. Resistivity. In your past paper questions, sometime examiner asks you to calculate resistivity. So what you will do, you will use this formula, resistance will be given to you, length will be given to you, area will be given to you, and you can find out this resistivity. That will become Ra upon L, resistance into area over length. So this is the formula which you have to remember. In formula sheet, it is given over there. Okay? So rho is the resistivity, and this is the complete formula. Now,